Okay, I think we'll get started. So today we're going to interface the LuckFox with an LCD display. Earlier we had done an OLED display, but sometimes you might want a different type of display. And actually, this is not as straightforward as it is with, say, the Raspberry Pi Pico. So a little bit of trickiness here. So I think we'll go through that. We're going to communicate via I2C. So a raw LCD display does not have, just has a bunch of pins you interface with. So usually when you buy these, they're connected to some converter that runs those pins into the I2C interface. And there's a standard so-called backpack which uses the PCF 8574 chip, and this is fairly standard, and so the packages, the Python packages, typically use this setup. But interestingly, the Waveshare uses a different setup, and so when you try to interface with the Waveshare LCD, it doesn't work. So I thought I'd include this as well, because since Waveshare is the primary distributor of the LuckFox, you may have bought the LuckFox and your LCD display from Waveshare, and there'd be a little frustration if you try to go back and forth. And even here is a little tricky, so we'll go through that. Just a couple of references here. If you're not following along and already through Lab 12, and you're just coming to this directly, the LuckFox tutorial page is excellent. That's all written. If you want to see a video on how to set up the LuckFox so that it has Ubuntu running on it, which is what we're doing, then there's a great video by Fusion Automate. His webpage, or his YouTube channel called Fusion Automate, has a really good tutorial on setting that up. And that's what we used, that's what we started with in this series. Then our first video went through setting up most of the Python stuff, and then you will want to watch video number 5 to get your LuckFox configured for I2C. And I think that's the video where we also bring in the package SMBus2, which is an important Python package. We're going to need one more additional Python package for running this standard set. And then we're going to build our own driver. Well, we're not going to build our own driver. Gemini helped me build the driver, and we'll just use that driver for this. Okay, so let's go to the computer and start to go through this. Okay, so we're going to be working with the two typical LCDs. This is the 1602, so it's a 16 pixels by 2 rows, or 16 pixels by 16 columns by 2 rows, I guess. This one is the one by Waveshare, and then, or sold by Waveshare, and then this one is just I got on Amazon. The Amazon one is right here, and so relatively cheap, a really nice cheap display. And you'll notice both in the picture, and then if I turn this over here, this is that so-called backpack, and this PFC 8574 chip is right here. There's a little trim pot here that you have to adjust to get the contrast right. The Waveshare, which is over here, I think. Let's see. Guess let me go to the top here so we can see. This is also quite inexpensive. The back side of this, there's no trim pot, so there's no adjusting the contrast. Very simple interface here, just the I2C pins. This does not run on the standard with that standard chip, so the typical package for that, Python package for that, won't work here. Now, Waveshare has example code for using this with a Raspberry Pi Pico running MicroPython, and that works just fine. I've used this. I think I've used this one with a Pico before, but here with the LuckFox, we don't have all the luxuries of the Pico, so we got to get that figured out for trying to run this one on the LuckFox without using the MicroPython packages. Okay, so let's just very quickly look at the LuckFox setup, and notice mine is upside down here compared to this. So I always have a printed out sheet, and then I turn it upside down. I have to read upside down, but at least this gets my pins aligned with how I have this on my breadboard. But we'll just look here quickly. We're going to utilize the ground and then the 5-volt bus. And I chased my tail on this for a long time. I had originally plugged in the LCD screen with the 3.3, and when I didn't notice it at first. When I turned the trim pot all the way one direction, so I thought I'd turn the trim pot all the way one direction, the other direction. I didn't see any output. So I was working on that, and then I noticed there was a very fine hint of an output way at the extreme of the trim pot here, and so it was because I had the supply voltage at 3 volts, and the range of that trim pot wasn't enough for me to really see the image. So when I plugged it into the 5, then it just worked just fine. So plug right into the 5 volts. So that's the V bus. The LuckFox itself, remember, runs on 3.3 volts, and you never want to supply a LuckFox pin 5 volts. So you always want to work with a 3.3 volt logic there. And then we are using, if you followed along in this series, we are using the bus number 3, so the I2C 3, so that's going to be physical pins 9 and 10, calculated pins here 58 and 59, respectively, for the SDA and the SCL pins. Okay, so I think we're about ready to plug this in and get going. So I'm going to pause the video so you don't have to watch me plug everything in, but I'm just going to simply I'm going to start with the Amazon one, the kind of typical one, and I'm just going to get that plugged in. Then we will go through a little PDF guide that I made up for helping us get through getting this all set up and running correctly with our programs. So let me pause, and then I'll come right back. Okay, so we've got it plugged in now, just as we were talking about over here. So we can see this light up, ready to go, but we haven't done anything with it yet. Okay, so what's the next step here? So I guess I should take me back. Let's go back to Google. So just start on Google, and we want to find our website for this. So we'll go Darren Olness, and then teaching LuckFox, and this is our page here. So we're all the way at the bottom so far here, so we're going to click on this LuckFox setup guide, and that will take us to the PDF of this. I am going to just take the printed copy of this and set it up right here. So hopefully you'll be able to follow along if you can't see this directly, but I think if you're looking at your PDF, we'll kind of just highlight some of the things. So we're going to start with the standard one. That's the one we've got hooked up. So first thing we need to do is get ourselves over in the terminal. So here we are in the terminal, and I'm going to just make sure. Yeah, I did a kind of a hot setup, so I didn't unplug the LuckFox when I set up my LCD. Maybe ill-advised, but I guess I'm too impatient. So I did that, and sometimes that will kick you out of the session with the LuckFox. You just have to log back in. Okay, so don't need this. let's look now at getting this set up. So if you've been following along, our Python is all set up to a point here. Now, what we're going to want to do, and I also, if you've been following along, you should be set up here. I'm going to do this. It's going to say that these are already installed, but I'll go sudo apt get the I2C tools, because we're going to need that to figure out the address of our LCD. And yours might be different than mine. So this is an important step that we need to do. I2C tools. Okay. Let me make sure. Unable to locate. Well, let me just, I guess we'll just try it, and if not, we'll have to come back here. Now, the other thing we're going to need is SMBus2. So I've already got this installed, so you'll go sudo pip install SMBus2. And I'll either tell you for the first time or remind you, the LuckFox tutorial will tell you to install SMBus, and then things won't really work. So you got to use the SMBus2 Python package. Okay, so this is already installed for me, so I'm not going to install that. And then the last thing we're going to need to do is pip install. This is this RP LCD. This is that standard package. And again, it is installed on my device, so I'm not going to install it. But here we are. Okay, so hopefully I've got those all installed successfully. And let's now go ahead and set up or figure out what our address is, what our I2C address is. So the important command here is sudo I2C detect, and then -y, and then the bus that you're using. So we set up, if you're following along, we set up the bus number 3 on the LuckFox. So the I2C 3. So the fact that we're using these pins here, I2C 3, right? I've got them upside down. Now I'm going to turn this over. So the I2C pins, so facing the way our LuckFox is facing, we're using I2C bus number 3. So I have to put a 3 here, and then we get the output, and notice what you want to look for here is this number, and it's usually 27. So most likely yours is going to be 27. So if you buy these on Amazon or most places, and you have this particular backpack on it, then it should be 27. But whatever it is, you want to grab that, or you want to write that down, because that's what we're going to need here. Okay, let's now go back and well, let's write a Python program. So let's go sudo nano. We can call this LCD practice. Whatever you want to call it. So we get a fresh text box here, and now let's bring back up our website, and let's grab here this PCF 8574. So that's the particular backpack here. This is I'm saved these as a text file, but they're really Python files. So go ahead and grab all of this. Make sure I don't grab extra stuff like I tend to do here. So I'm going to grab that, bring this back down, and then paste that into here, and hopefully everything looks good. And so I will go Control X and then Control Y, and we should now be able to run this. So let's go sudo nano Python 3 LCD practice. Oh, and got the wrong port here. Okay, I'm going to check on this, and so I'll pause the recording and come back. Okay, I apologize for that. I had the wrong code on the website. It's right now, so the code that you have should be correct. So hopefully yours already worked, but let's try to run this now, and we'll try to watch the screen. So we'll go sudo Python 3 practice. So what we should see here is we see hello from GNL project come up on the board, and then we're going to see it go off, shut off the backlight, and turn the light back on. And so that's a little test program for the basic or standard LCD. So hopefully that grabbing that code can get you going on this device if that's what you need. All right, so let's switch gears over to the LuckFox or the Waveshare version. So I'm going to pause the video again. I'll do a change of the change out, switch these out, and then we'll pick back up. Okay, so let's start now with the Waveshare. So this this uses the AIP 31068, and we can get some information about that with the data sheet. So where do we find that data sheet? Well, if you go to the LuckFox or I keep saying LuckFox, but Waveshare site for this. And then if you scroll to the bottom somewhere, you can find the tutorial resources. Yeah, right here, this resource page. So we'll click that. And here we go. And then if we can go all the way down to datasheet, then you can get the user manual here, and you can get the data sheet for the AIP 3168. Now, we're going to not look too much at this, just a few pages here. I really just fed this to Gemini Pro, and we went back and forth and got a driver written based on the information here. And what's going on here is that all it really is that the pin assignments are different, but the number of combinations, or it's just really, there'd be no way to just by brute force figure that out. So you really do need to look at the data sheets. And so in here, there was enough information to get that. Just some real quick things. You can get the power is normal, 5-volt power here. Let's see. Again, we're using this address or this chip. The datasheet says the address is 7C. We're going to find out that's not the case. So that's kind of an important thing. Now, it could very well be for the one you have, but it's not the case for the one I have. So we will go through that same I2C detector and get the address. And then finally, the pin map, there's a table here somewhere. A table here in the back. So with this information, Gemini was able to write up a pretty good driver. So we'll grab that driver, we'll create a file and copy that in, and then we will grab a test program as well. So let's go ahead and do that. So we'll click back to our website here, and let's grab the driver now. And hopefully this is, I won't have to pause the video and find the right program. I think this is correct. So I'll grab this, and then we'll go to the terminal, and we'll go sudo. This, we do want to get this exactly, well, we want to give it a file name, and then we're going to call it in the next file. So let's actually use this same file name. So we'll call this sudo nano. We want to get this right now. So AIP 31068 LCD driver.py. So it's just going to be a Python script, but we want to have the right name. Then we will paste this in, and then simply exit, save. Now that driver will be in our, so that driver should be right here. I think I might have it incorrect. I got two versions here. So we want capital P, this one. So make sure, if you copied me directly, I might have used a small p there. So capital P here. I have it in there, so it should work. So now we'll go sudo nano, we'll go Waveshare LCD.py. Then we'll go back to our site and grab this test. We'll test it. And well, let me get this in here first, and then we'll check it. So what we want to check now is, yeah, it's a capital P. So make sure this is the same name as what you named your driver. Sorry for the abrupt jump here. I had promised to detect our address on the I2C and forgot to do that. So let's do that. So we'll go sudo I2C detect -y3, and we can see here now that it isn't 7C or whatever the manual said. It's, in my case, it's 3E. So go sudo nano Waveshare LCD.py, and this right here is what you will need to change to whatever it is for you. So it's 3E for me, and so you'll want to change that for what you need. All right, that's how we do that. So let's hope this works now. Turn that so you can see it. And there we go. This was supposed to be over, so it was testing whether we can move it over a row. So you can go back into that code and kind of play with the print statements, find that, and make sure you've got that working on your device. So didn't do any real science here, but we looked at interfacing with these LCDs, which could be a very useful thing if you're trying to build an instrument or just other aspects of your project. All right, that's it.